This video will be a quick review on angle relationships and triangles. Let's just jump right into it. We are going to classify each triangle by its angles and sides. So let's look at triangle ABE. If you follow from A to B to E, they're talking about this triangle. Okay. If you look, you see the right angle there. So I know it's a right triangle. And so that's classifying it by angles. But look at the sides. All three sides are different lengths. So it is a right scalene. That's how you do it, by angle and by side length. Triangle BEC. If I go from B to E to C, I see that I have an acute scalene triangle. All three angles are acute, and all three sides are different. So it's acute scalene. If I look at triangle DEF, from D to E to F, so I'm talking about this triangle, and if you notice, all three sides are the same, so it is equilateral. And if all three sides are the same, so are all three of those angles. And of course, all three angles of a triangle add up to equal 180. So if they're the same, 180 divided by 3 is 60. So each angle is 60. So that makes it an acute equilateral triangle. And last, triangle CDF. If I go from C to D to F, I'm talking about this triangle. Excuse my line, y'all. But I just want you to be able to follow it. So CDF, I have one acute angle here, right? Because if this is 60 degrees, I know that's 120 degrees. And so I have one acute angle. So I know it's one obtuse angle. So I know this is an obtuse triangle. And if I look at all the sides, that's 2, that's 5, and of course that's neither 2 nor 5. So that is scalene. So next, given the coordinates, we're going to classify a triangle ABC by its sides. In order to classify by its sides, we have to know the length of each side. When you're given coordinates, you would have to use the distance formula. x2 minus x1 squared plus y2 minus y1 squared, all under the radical. So first, let's find the distance between A and B. So here's, I'm going to come down here and write it again. A is 2, 3, and B is 6, 3. So this is my first set of coordinates. So let this be your first set, x1 and y1. This is my second set, and so this is going to be x2, y2. And then I just come and plug it into our formula. I have D equals x2, all under the radical. x2 is 6 minus x1 is 2, and that's going to be squared, plus y2 is 3 minus y1 is 3, and that's going to be squared. Use your calculator to check your work. It's okay. 6 minus 2 is 4, and 3 minus 3 is 0. So now I square 4, which is 16. 0 squared is 0, so that distance is the square root of 16, which is 4. So the distance from A to B is 4. So like if we had a segment there, that distance is 4. So now let's find the distance from B to C. You do the same thing. So now let's do B as my first set of coordinates. So 6, 3. And then C is 2, 7. And so now B is going to be my x1, y1. C is going to be my x2, y2. And I plug it into the distance formula. x2 is 2 minus x1 is 6. That's going to be squared, plus y2 is 7 minus y1 is 3. Always label so that you don't mix yourself up. It's easy to do it. So I have 2 minus 6 is negative 4, and that's still squared. And 7 minus 3 is 4. and that's squared. All right, so -4 is in the parentheses, so it's saying -4 times -4. And a negative times a negative is a positive. So it's positive 16 plus 4 squared is 16. And so I have the square root of 32. And if you need to write that in simplest radical form, you just find the largest perfect square that goes into 32, which is 16. And 16 times 2 is 32. You take the square root of 4 and that, of 16, and that goes out front. And so I'm left with the 2 in the under the radical, and so it would be 4 root 2. So the distance between point B and C of this triangle is 4 root 2. All right, last we're going to find the distance. So from B to C, there, let's write that down. It's 4 root 2. And last, we're going to try to find the distance between A and C. A is 2, 3, and C is 2, 7. Do the same thing. Always label it x1, y1, x2, y2. It just helps to see it. x2 is 2 minus x1 is 2 squared plus y2 is 7 minus y1 is 3 squared. 2 minus 2 is 0 squared. 7 minus 3 is 4. And then squared. Of course, 0 squared, 0 times 0 is 0. 4 squared is 16. So I have square root of 16. And the square root of 16 is 4. So from the distance from A to C is 4. So this is how it looks. Let's draw. A, B, C. From A to B was 4. From B to C was 4 root 2. And from A to C was 4. So if you look, two sides are congruent. So you have an isosceles triangle. Here we are going to find the measure of each missing angle. And to do that, let's start with angle 1. If you look, you have your straight line, and the measure of a straight line is 180 degrees. So I know that together, these two angles have to add up to equal 180 degrees. So 180 minus 89 is 91. So I know that angle 1 is 91 degrees. Next, I see I can't fill in anything else. I don't have enough information, but I do see a pair of parallel lines. If you look here, these marks mean that they are parallel. Now, y'all know about my straight lines right now. So let me see if I can draw a straight line for you. Something like that. That's pretty good. So you see these two parallel lines. I'm going to extend them. So if you see here, this line is parallel. This line is the transversal. This line. Again, sorry about my straight lines. And if this is a transversal, I have some corresponding angles. This angle and this angle are corresponding angles. So that means if they're corresponding angles, they both are 65 degrees. All right, so since angle 1 is 91 degrees, angle 2 is 65 degrees, we can easily find the measure of angle 2 because we have a triangle. And we know that the sum of the angles of a triangle, those interior angles, are, that is 180 degrees. So 180 minus, here I write it up here, 180 minus 91 minus 65 is 24. So the measure of angle 2 is 24 degrees. All right, let's go to angle 4. Angle 4, if you look, all of these angles, these three angles, should add up to equal 180, right? Because you still have a straight line, and the measure of a straight angle is 180 degrees. So you would say 180 minus 65 minus 82, and that should give you 33 degrees. All right, and so last you just find angle 5. It's like a puzzle. You feed off the previous step. This is a triangle. All three of these angles should add up to equal 180. So you would say 180 minus 65 minus 33, and that gives you 82. So angle 5 is 82 degrees. When you look at this figure, I want you to just take your time and see all of the triangles here. If you look at angle 3, 5, and 6, that's one triangle by itself. Here, the 68 degrees and the 90 degrees. If you look, that is a larger triangle if you follow my marker. Here's another larger triangle. Angle 2, 1, and this 85-degree angle. These are all triangles, and no matter how you separate them, each triangle, the sum of those angle measures is going to be 180 degrees. We have more than enough information. We could start in so many different ways. Like here, I see a 120-degree angle. I know the angle 2 would have to be 60 degrees. Right? Straight line. And it is a linear pair. These two, so they add up to equal 180. Also, I know that angle 3 would be 120 degrees. I can see vertical angles, and they're always congruent. Or I could do 60 and 120 is 180. And here I know angle 4 is 60 degrees. So I can fill it in just many different ways. Let's first solve for angle 1. And I see this triangle with angle 1 and 2. And if I know that this is 60 degrees and this is 85 degrees, I just subtract 180 minus 60 minus 85, and that gives me that third angle. So that gives me 35 degrees. And I do the same. Pause the video and try to fill in this figure, and then restart it, and let's see if we came up with the same answers. All right, so I see this large right triangle. I have a 68-degree angle, a 90-degree angle, and let's see what angle 5 would be. You would subtract 90 minus 68, and that will give me 22 degrees. So this is a 22-degree angle. Now that I have enough information, I can solve for angle 6. 180 minus 120 minus 22 to give me that third angle. And that is 38 degrees. And so here. Last, we have angle 7. Of course, that's not part of a triangle, but they do lie on a straight line. So we know it's 180 degrees. So you would say 180 minus 38, and that will give me 142. So 180 minus 38 equals 142. So angle 7 would be 142 degrees. All right, here we have to find the value of y. We have a triangle, and what do we know about these three angles? Always, they will add up to equal 180. So you would say 8y plus 5y plus 6 plus 3y plus 4 equals 180. First, we combine like terms. 8y and 5y and 3y, you add those, you will get 16y. 6 plus 4 is 10 equals 180. I subtract 10 from both sides, and I get 16y equals 170. I then divide both sides by 16. They cancel, and y is going to equal 10.625. Sometimes you won't get a whole number, but as long as you know what you're doing, your answer is correct. So if you were to plug all of y back in, you should be able to add these three angles up and get 180 degrees. Give that a try. All right, these two remote interior angles add up to equal the exterior angle. So you would say 4x plus 3 plus 7x minus 28 equals 13x minus 80. You're going to combine like terms to solve for x. 4x plus 7x is 11x. Positive 3 and negative 28 is negative 25 equals 13x minus 80. All right, let's go ahead and subtract 13x from both sides, only because I want to leave my variables on the left. 11 minus 13 is negative 2x minus 25 equals negative 80. These cancel, so I just brought my negative 80 down. Next, we add 25 to both sides. Use your calculator, guys, if you need to. Bring this down, negative 2x. These cancel, the 25s did, and that leaves me with negative 55. Next, I divide both sides by negative 2. And that gives me x equals 27.5. I like to give problems like this because you won't always have a whole number, guys. As long as you do it right, you can plug it back in, but as long as you understand that these two angles add together to equal this exterior angle every time. If you have any questions, feel free to email me.